Hi, good afternoon. We're team number 3. We work with the parking ticket data and trial data. My team members are Kim Chow, Mark Fruman, and myself. Well, parking tickets are both a way to enforce compliance with parking regulations, but are also a source of income for the City of Toronto. 2.2 million parking tickets were issued and collected in 2015, and they generated $55 million in revenues for the city. There's a certain number of tickets that get contested every year. Last year, 231,000 parking ticket recipients requested a trial. And those tickets don't get paid until the trial takes place. The city has to wait. That's approximately $5 million that the city receives 12 months later or more. There's also a backlog of contested parking tickets. In 2015, the city decided to cancel 880,000 unpaid tickets that were issued between 2002 and 2014, and this is estimated $20 million in revenue that were lost. So, what if the city could know what tickets are the most likely to be contested and what trials are the most likely to be won? That's the focus of our solution. Create a machine learning model that predicts the likelihood that a parking ticket will be challenged and eventually dismissed in a trial.
Do you have the link to the notebook straight away, or is it the slides?
Well, first of all, we need to be able to make this analysis, to be able to build that model. We need a lot of data to be able to predict the outcome of whether a parking ticket could be challenged and eventually won in a trial. Some of the data that we have used in this machine learning regression problem is the address points that the City of Toronto provided on its website. We have used the address points and the intersection data because we have not been able to get the coordinates from an open source coordinate provider, because we have a limitation on getting those data within a limited amount of time. And then we have tried to use the weather data from the Toronto, for Toronto, from the Environment Canada website. And then we of course we have to use the parking tickets information from the open data website and the trial tickets. Let me show you. Whoops. This is the format of the data from what we have from the website of City of Toronto, which locates in terms of addresses, like they have multiple fields for each parking ticket that has been issued, and the last 5 digits of the parking ticket number, and the data of infraction. How do we get that?
just want
notebook.
to slide across.
The notebook.
Here?
No, the other one.
Which one?
The first notebook.
I don't know which one is the one. And this is.
Yes.
Which one?
So I'm going to show you some of the data exploration we've done just to have an idea of what of the data we have tried to merge together. How do we do that?
Yeah. Perfect.
So the intersection data, the intersection file that we've got, contains about 500,000 addresses, and it gives us the longitude and latitude of the data, which we then concatenate with the address field of the previous data set that from the parking tickets, where we could be able to get the longitude and latitude, the coordinates of each and every address, so that we can plot it eventually on the map and see how the data can be visualized using a useful map. We then try to use the weather data, where we got the temperature, the daily temperature, the actual temperature, and the amount of rain, the precipitation, and the snow on the ground for every day. And then this is a trial data that all the tickets that has been contested by drivers for the year 2015. Yeah. And then what we've done is to try to merge this data together with the initial parking tickets data by intersecting the data using the last 5 digits of the ticket number with the date of infraction. Right. So this is the final data that we've got from the 5 data sets that we have manipulated and explored, so that we got a full set of data that can be used eventually to do the machine learning regression program. I'll now invite Mark to continue with the regression.
Okay, so in parallel with building our machine learning model, we obviously did some more data exploration, looking at how the likelihood of a ticket being challenged would depend on these features. So can I have the visualization? No. Okay, so I'll show you a few examples of visualizations we could do to study the data. So for example, this is a visualization. This is showing the number of tickets issued per hour of the day as a function of latitude and hour of the day along Bathurst Street and Yonge Street. So this gives you an idea of how, depending on the time of day, you have more tickets issued and eventually challenged. So in terms of our predictor of our target variable, this is the fraction of tickets challenged per hour of the day. So you can see that in the early morning hours, in the overnight period, a smaller fraction of tickets end up being challenged. and the most tickets challenged are during the late morning and early afternoon. Similarly, we can get some dependence on the day of the week. Evidently, fewer tickets relative to the number of tickets issued are challenged when they're issued on the weekend. Quite intuitively, the higher the amount of the fine, the more likely the ticket is to be challenged. So it's 20% of the tickets that are $450 are challenged. This is an interesting one. So what we did was we had the latitude and longitude information, but it's too fine scale. So we binned the city into, or the latitude longitude intervals of the city into 400 blocks. About almost half of them are lost to Lake Ontario. But this is the fraction of tickets challenged per latitude longitude bin. Okay, so you won't see any information what these bins are, but you can see that there's very different behavior from bin to bin. This would capture things like the presence of a cultural space or a factory or a church or a hospital in a particular bin, which is people park illegally for various reasons. This is the same visualization. It's a bit harder. You can see the shape of the city, but it's a bit harder to see the quantitative information. This is dependence on the daily maximum temperature. You can see there's more information there. Our parking ticket trial data covered just a short period at the end of 2015. So naturally, the fraction of tickets challenged depends on, as a function of date issued, will vary accordingly, because some tickets will have already been processed before this period, or some will not have yet have been processed. So we test our event, ultimately we test our model on a period where the fraction is relatively constant. Okay, this is a nice picture, the neighborhood of Wattpad. The red dots represent tickets issued and not challenged. The blue dots represent tickets issued and challenged, so we can get very fine scale data from our set. Should I go to the machine learning? Yeah. So we use the data to train a logistic regression model to use all of these features to predict the likelihood that a ticket will be challenged. Okay, I won't go through the details, but what was interesting from a data Spark point of view is most of these data, some of them are continuous, like the temperature and so on, and some of them are apparently continuous, but the information contained is largely discrete. So we process the data by applying a pipeline where we first string index the categorical data. So this converts categorical data into the zero-based integers up to the number of categories. And then we converted them to one-hot encoded vectors, and finally combined all of our features into one feature column. And we trained a logistic regression model. And I'll skip to the result. This is the ROC curve for our model. And you can see that the area under the curve is a very respectable 0.8. So 0.5 for area under the curve corresponds to just a coin flip, basically. So we're doing a lot better than that. Our model outputs a probability that a ticket will be challenged, and then you make your decision relative to a certain threshold. So the threshold output for our model that we chose as optimal was about 0.06. Okay, so how much this might be used, for example, as Cesar will show, a citizen might want to know the likelihood of their ticket being challenged. So they would provide, where am I? They would provide, for example, the date of their ticket, the time of day, the infraction code, and the address where they received the ticket. And then it would apply our model and return a result of 0.381. It's a bit hard to see there. So that's less than the threshold. So we would recommend that, we would suggest that this ticket is less likely to be challenged.
Just to wrap up how we think that the city could use this information and this model, the city has in its website information about the different parking ticket procedures, how you can do to dispute a parking ticket. That's information that is available right now on the website. Also, the trial option that has certain process, like going to court, wait for your notice of trial, and then appear in court and plead no guilty. If the city with this information could calculate just with the information, the day, location, infraction type, and time, could calculate the probability that a ticket will be challenged, and also a citizen and the city could know could potentially know the probability of winning a trial. That would be the next step. You know, in this data source that we have, we don't have the information if the trial was win or not. Right? If we have that information with the same variables that we have here in the model, you could predict the probability of winning a trial, and that's helpful for the city, because if he has a big backlog of parking tickets that he has to analyze, maybe it could focus on the ones that it could win and or prioritize them, right? And also information helpful for the citizen, because sometimes a person can decide to challenge a ticket, but if he knows what is the probability that he will win and that is low, probably is going to decide not to challenge it, right? So I think both sides win with this information that could be available in the website of the City of Toronto. That's it. Thank you.
I don't know there. I can't stop laughing. I work for the city. This is very interesting, and I don't know if I can speak too much to the data, but I wanted to ask you a question about the address data that you were using. Is that the address of the infraction or the address of the actual infractee, or the person who...
No, it's the address of the infraction.
Okay.
I presume it's what the parking officer they'll probably press,
Yeah.
check my current location and enter it.
Different device, which they might get the coordinate and the exact address of the infraction that took place.
Right. Did you have access to, in that parking ticket data, to the actual owner of the vehicle and where they lived? I'm just wondering if there's a correlation between, crap, that's my street, I'm gonna, you know.
Can you repeat the questions after you?
Okay.
Or if in fact, you know, if there's somebody who's visiting, or it's a car rental company which has a different approach in terms of how they proceed, if that was a factor for you. So the question was.
I'll repeat it with a microwave, perhaps. The question was about whether we had demographic and personal information about the driver, or the registration. Location.
You could get address of the driver.
Address of the home address of the driver.
Yeah.
Yes. Obviously, the city would have this information, or the province would have this information from the registration. In the open data, for obvious reasons, they didn't make that. Yeah, so from the city's point of view, they would have that, obviously. Yeah.
I think your challenge raises some issues for us around, with this information, you want to spend resources wisely. You don't want to do what they did when they just walked away from millions of dollars, but largely because of course of justice had got skewed. And the role that issuing parking tickets plays around management of scarce resources, right? We don't want you parking in the bike lane or blocking other cars and congestion management. And I so is that sort of political layer that gets put on top of this? And I'm very interested in your concept of, you could go in and, as a consumer, as it were, play the percentages about the, is it worth my while to spend time in court? The one thing I'll say about the city, when we went to the website to look about how to challenge a ticket, we make it really hard. You have to show up in person. Like we do everything we can to disincent folks from doing exactly that, which is challenging a ticket. And you can go to trial and you can actually still plead guilty with extenuating circumstances, and you still pay some value on that original assessment. It's a bit of a crapshoot, but really interesting. Quite enjoyed it. Thank you.
Thank you.
Thank you.
More technical kind of question. So you used a logistic regression model. It's a very simple, straightforward model where all the parameters are independent of each other and roughly linear other than the output. So we don't know if any like weather and something, there's no interaction between those. Is there any reason why you didn't look for a more advanced model? Why you, like, there's a lot of different models available in MLlib. You sort of picked the simplest possible one first. Why didn't you go to try and
We used the PySpark ML library. Actually, we did run a random forest calculation, which is a bit of a black box. On the other hand, it had a slightly lower area under the curve result, but we didn't fine tune it. So.
And did you do any analysis of the individual features? Like I saw your visualization where you were sort of debugging some of the features, but if you were, did you come out with like, you know, this feature is the most indicative, or this one is the one that we shouldn't care the most about as we think about whether we should go to trial, or is it you need all of them for it to know?
It's a good suggestion, and we would do this normally. When you use the vector assembler in PySpark, you end up with something that a computer likes to read, but it's very difficult for a human. So we can output the model coefficients, which correspond to the one-hot encoded indices. So if we were doing this in production, we would have an inverse transform procedure. So yeah, we actually probably should have looked at the statistics of the coefficients just to see how many of the features were interesting and so on. Yeah.
But like one of the good reasons to do that is you're concerned about overfitting, but from your training, you didn't have that problem.
Looked like.
Yeah, we have 2 million data points, and we use 465 features.
So I guess you know, given what you explored and what you understood of like the problem space, what additional data would you want to have, or do you think would have improved the area under the curve for that particular predictive model?
Well, for sure, if you know something about what are how the police officers decide where to go in the city, if they have certain, I guess it's implicit in the data that they have certain restrictions in terms of number of police officers and how many police officers are available during the weekday and during the weekend. And also, they have been doing this for years, so they know where to go. You know, so the areas where people more likely will park illegally, they know where to target. So that's implicit in the data. But it will have been helpful to understand a little bit more how they schedule these rates.
Just the question was about what other information we might have wanted to have. Something I thought of doing, I mean, it's short of time and it's a bit of like all these toys. Maybe certain streets are, because of certain reasons, so a long street might have a lot of tickets on it. So we could have looked at the street names or popular street names, one-way streets, you know, so many things.
At the beginning of your presentation, you said you wanted to predict the likelihood of tickets being contested, and also the likelihood of if someone contested that they actually won. We saw a lot of information about the likelihood of being contested being dependent on time and things like that, but I don't remember seeing anything about that issue being won. Did I miss that, or?
No, that's because we didn't have the data of what happened with the trials at the end. But if we had that data, we can use the same features that we have to explain that class.
Okay.
We would have other features like the reason for the ticket being contested, right? That's something that the driver.
Okay.
Yeah.
But you have no data with regards to the actual
Outcomes.
If it actually outcome. Okay. The other question is, how would the city benefit knowing the likelihood of a ticket being contested? How would that change either the city's behavior, policies, ticket strategy, HR strategy? I don't know. How would knowing that piece of information benefit the city?
So the question is, how would the city use this information? I mean, the city. I think the city that the parking enforcement one feels as a citizen, the parking enforcement can give as many tickets as it decides to. So in terms of deploying resources, it would want to give as many tickets as possible that won't be contested, as apparently they go out of their way to prevent tickets from being contested. So this would be like a kinder way of.
I mean, that's in theory why it would help, but this is something that we have debated as well, and how helpful it is for the city. And we saw this as part of a process to get to the calculation of the probability of winning, because I think that's information that it will help the city, especially when it decides what tickets to target from its backlog, and also information that could potentially help the citizens choose their actions. You know, so we understand that there are certain limitations in terms of how to use from a policy perspective the information of probability of challenge.
I was wondering as well about the utility for the city without having the second part of what's the probability of winning, which I think greatly, by an order of magnitude, probably increases the value of this. But probably if you had the reasons for contest and things, there's a quality control aspect that they can apply to this, because if one area has frequent missing data on the tickets, and that's the reason for contest, then all tickets are not being issued equally, and they're probably some corrective action that they can take on their own processes. Well, yeah, could be badly indicated, or they just have some careless execution by certain members of the parking enforcement staff. But you still need to get a little more data than you have because of contest reasons.
That data would be particularly useful, why the ticket was contested. Yeah.
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 And I think the city could use this kind of information to evaluate after the trial's outcome, how well why the reason behind why these tickets have been dismissed, and because it costs a lot of money for the city, I believe, to actually in terms of administrative costs to incur to administer all these parking tickets and trials, and the judges' time as well. So maybe with more information, the city can use this data, this final outcome, to better train their police, parking enforcement officers, to better take parking. Not like maybe some parkings were not justified. Some tickets were not justified enough, so that they could better control their parking tickets. Maybe sometimes I believe they got the quotas to do, and they just issue parking tickets just to make the quotas. Maybe.
Sorry, one other metric that I think you would have had the data to check is the number of contests from the same person. Did you track for that? Because I have an intuitive sense that there are a few people that collect a lot of tickets and contest them all.
Yeah,
the first three letters of the last name,
that's something interesting. Yeah, but it was in the data set. They tried to cover that, so they just put the three first letters of the name. Yeah, but it's interesting.
I think you make a very good point. It almost doesn't matter what happens after the trial, because it's so expensive to run the trial, and if they're contested, the city's basically losing money on that ticket anyway. So it is really optimizing whether you give out the ticket or not. Is a very valid way of approaching it.
All right.
Try 50 at once for this.
Sure.
What was the question? Somebody asked a question?
Easy question.
No.
think just a comment. The better utilization of your finding, what kind of ticket will have the most challenge, and you have a reason for why they do challenge. And the quality control training of the enforcement officer will go a long way of helping them issue tickets that cannot be charged, and therefore save the city a lot of money. And unfortunately, we don't have that information, but I would see that would be the most opportunity for the city to improve the likelihood of not losing income on the parking.
Thank you.